Have you ever wondered what it would be like to stand on the surface of Mars or explore the icy moons of Jupiter? The idea of traveling to other planets in our solar system captivates our imagination, sparking dreams of adventure and discovery. But here's the big question: why is it so hard to go to the planets of our solar system? Throughout this video, we'll dive into the complexities and futuristic technologies needed to make such journeys possible. From immense distances and harsh environments to technological limitations and mind-boggling challenges, we'll uncover the reasons behind the difficulties and what the future holds for space travel. Trust me, you won't want to miss a single moment, so stay with us until the end of the video to explore these fascinating topics and discover just how close or far we are from making interplanetary travel a reality. The first challenge involves the technological limitations of our current space travel capabilities. Right now, our primary method of reaching space is through rocket propulsion, a technology that's fundamentally based on principles developed in the mid-20th century. While rockets have evolved over the decades, they still face significant limitations in both speed and efficiency. For instance, conventional chemical rockets require enormous amounts of fuel to escape Earth's gravity, which translates to high costs and limited payload capacities. This not only makes missions expensive, but also restricts the amount of scientific equipment and supplies we can send. To reach the planets of our solar system, we need to travel vast distances. For example, Mars, our closest neighbor, is about 225 million kilometers away on average. With current rocket technology, such a journey could take around 6 to 9 months. Now imagine traveling to the outer planets like Jupiter or Saturn, which are several times farther away. The time and resources required for these missions become exponentially greater. This is where the need for advancements in propulsion technology comes into play. Scientists and engineers are exploring various futuristic propulsion methods that could revolutionize space travel. One promising approach is ion propulsion, which uses electricity to accelerate ions and generate thrust. This method is far more efficient than chemical rockets, allowing spacecraft to achieve higher speeds over longer durations. Another exciting possibility is nuclear thermal propulsion, which could potentially cut travel times to Mars by half. By using the heat generated from nuclear reactions to produce thrust, these engines could offer a more powerful and efficient alternative to current technologies. However, these advanced propulsion systems are still in the experimental phases and face numerous technical and regulatory hurdles. Developing and testing these technologies safely requires time, funding, and international cooperation. Moreover, there are significant engineering challenges to address, such as the need for reliable power sources and sustainable life support systems for long-duration missions. In addition to propulsion, we must also improve our spacecraft's capability to protect astronauts from the harsh conditions of space. This includes shielding from cosmic radiation, managing extreme temperatures, and providing adequate medical care in the event of health emergencies. Radiation exposure remains one of the greatest risks for long-term space missions, especially beyond the protective magnetic field of Earth. Advanced materials and innovative shielding techniques are being researched to mitigate these dangers, but there's still a long way to go. As we look to the future, it's clear that overcoming these technological challenges is crucial for making interplanetary travel a reality. Each advancement brings us one step closer to exploring the planets of our solar system. So, while the obstacles are daunting, the progress being made is incredibly exciting and opens up a world of possibilities for the next generation of space explorers. The second challenge involves the vast distances and time required to travel to other planets in our solar system. Imagine the immense journey from Earth to Mars, our closest neighbor. Mars is about 225 million kilometers away on average. Even with our current rocket technology, a one-way trip to Mars would still take around 6 to 9 months. Consider what that means in terms of time and resources. Now, think about traveling to the outer planets like Jupiter or Saturn. Jupiter is roughly 778 million kilometers from Earth, and Saturn is even farther at 2 billion kilometers away. With current technology, these journeys could take several years. To put this into perspective, let's compare these travel times with something more familiar. Driving across the United States from coast to coast takes about 5 to 7 days by car. In contrast, traveling to Mars would be like making that trip over 1,000 times consecutively without stopping. And reaching Jupiter or Saturn, it's like making that same cross-country trip tens of thousands of times. These long durations present significant challenges for human missions. Prolonged exposure to the microgravity environment of space can lead to muscle atrophy and bone density loss. Astronauts on the International Space Station already experience these issues after months in orbit, so imagine the impact on a multi-year mission to the outer planets. There's also the psychological toll of spending such long periods in confined spaces, far from Earth. Maintaining mental health and social cohesion among crew members is crucial for the success of long-duration missions. Moreover, the longer the journey, the more supplies are needed for food, water, and medical care, which increases the mission's complexity and cost. The vast distances also impact communication. For example, it takes about 13 minutes for a signal to travel from Mars to Earth, meaning that real-time communication is impractical. For missions to more distant planets, this delay becomes even more pronounced, complicating mission operations and requiring astronauts to be more autonomous in their decision-making. These vast distances and extended travel times underscore the need for advancements in both propulsion technology and life support systems. By developing faster and more efficient propulsion methods, like ion propulsion or nuclear thermal propulsion, we can significantly reduce travel times and make interplanetary missions more feasible. Equally important is the development of sustainable life support systems that can ensure the health and well-being of astronauts over these long journeys. So, while the distances and time involved in traveling to other planets pose serious challenges, ongoing research and technological advancements are steadily bringing us closer to overcoming these hurdles. This will ultimately pave the way for humans to explore and possibly even settle the planets of our solar system. The third challenge involves the harsh conditions of space. Space is an incredibly hostile environment, and surviving there requires overcoming several severe challenges. One of the most well-known issues is zero gravity or microgravity. While floating weightlessly might sound fun, long-term exposure to zero gravity can have detrimental effects on the human body. Without the pull of gravity, our muscles and bones start to weaken and atrophy. Astronauts on the International Space Station exercise for about 2 hours each day to combat muscle loss, but even then, they still experience significant bone density loss similar to osteoporosis. Another major challenge is radiation. Space is filled with high-energy particles from the sun and cosmic rays from outside our solar system. Earth's atmosphere and magnetic field protect us from most of this radiation, but once astronauts are beyond these shields, they are exposed to much higher levels of radiation. This can increase the risk of cancer, damage the central nervous system, and even cause acute radiation sickness. For missions beyond low Earth orbit, such as to Mars or the outer planets, radiation exposure becomes a critical concern. Engineers are developing advanced shielding methods and materials to protect astronauts, but creating effective protection that is also lightweight enough for space travel is no easy task. Extreme temperatures also pose a significant challenge in space. In the vacuum of space, there is no atmosphere to moderate temperatures. This means that spacecraft and astronauts can experience intense heat when exposed to the sun and extreme cold in its shadow. For instance, on the Moon, temperatures can swing from a scorching 127 degrees Celsius in the sunlight to a freezing minus 173 degrees Celsius in the dark. Spacecraft must be designed with robust thermal control systems to manage these temperature extremes and keep equipment and humans safe. These harsh conditions not only affect humans but also the spacecraft and equipment necessary for missions. For instance, electronics can malfunction, materials can become brittle and break, and life support systems must work flawlessly to ensure survival. Examples from past missions highlight these challenges. During the Apollo missions to the Moon, astronauts experienced the effects of zero gravity, extreme temperatures, and had to rely on their spacecraft's life support systems to protect them from the vacuum of space. The Apollo 13 mission is a stark reminder of how unforgiving space can be. When an oxygen tank exploded, the crew faced extreme temperatures and limited power, relying on their resourcefulness and training to survive. As we plan for longer missions to other planets, addressing these harsh conditions is paramount. Innovative solutions are being explored, such as artificial gravity systems to mitigate the effects of zero gravity and employing water or specialized materials for radiation shielding. Advanced thermal regulation technologies are being developed to handle the temperature extremes of space. Overcoming these environmental challenges is essential for ensuring the safety and success of future interplanetary missions. The obstacles may be daunting, but the progress being made is bringing us closer to safely exploring the wonders of our solar system. The fourth challenge involves the unique and harsh atmospheres and terrains of different planets in our solar system. Each planet presents its own set of extreme conditions that complicate landing and survival. Take Venus, for example. Venus has an incredibly thick atmosphere composed mainly of carbon dioxide with clouds of sulfuric acid. The atmospheric pressure on Venus's surface is about 92 times that of Earth, akin to being a kilometer underwater. Coupled with surface temperatures that average around 467 degrees Celsius, this makes Venus an extremely hostile environment where conventional spacecraft and instruments will be quickly destroyed. Mars, our closest neighbor, has its own set of challenges. Mars is known for its massive dust storms, which can cover the entire planet and last for months. These storms not only reduce visibility, but can also damage equipment and interfere with solar panels that power rovers and habitats. Additionally, the thin atmosphere of Mars, composed mostly of carbon dioxide, makes landing safely a difficult task. There is not enough atmospheric density to slow down a spacecraft sufficiently using parachutes alone, necessitating complex landing systems involving rockets and airbag systems to ensure a safe touchdown. Europa, one of Jupiter's moons, presents a different kind of challenge. Europa's icy surface hides a potentially vast ocean beneath it. While this ocean is a tantalizing target for the search for life, the ice crust poses significant difficulties for landing and exploration. The terrain is treacherous with potentially sharp and uneven ice formations, and the temperature on Europa can plunge to minus 160 degrees Celsius. Developing landers and drills that can operate in such a cold and icy environment while keeping instruments warm and functional is a significant technical challenge. Other planets and moons present their own unique terrains as well. Titan, Saturn's largest moon, has lakes of methane and ethane along with a thick, hazy atmosphere. Any lander or rover on Titan would need to be equipped to handle the cold temperatures, the liquid methane, and the low visibility. Contrast this with the rocky and cratered surfaces of Mercury and our own moon, which present their own navigation and landing challenges. These atmospheric and terrain conditions require specialized technologies and approaches for each destination. For instance, engineers are designing heat-resistant materials and robust landing gear to withstand Venus's extreme conditions. For Mars, they are developing dust-resistant technologies and advanced landing systems. On icy bodies like Europa, specialized drills and heaters are being created to penetrate the ice and explore the subsurface oceans. In summary, the unique atmospheres and terrains of different planets and moons not only make landing and survival a complex task, but also drive the innovation of specialized technologies tailored to each environment. By overcoming these challenges, we inch closer to the dream of exploring and understanding the diverse worlds within our solar system. Stay with us as we continue to uncover the remarkable science and technology paving the way for future interplanetary missions. In summary, the journey to the planets of our solar system is fraught with numerous challenges, from technological limitations and vast distances to harsh space conditions and the unique atmospheres and terrains of different celestial bodies. Each of these obstacles requires groundbreaking advancements in propulsion technology, life support systems, radiation shielding, and specialized landing techniques. Despite these daunting hurdles, the relentless efforts of scientists and engineers are steadily pushing the boundaries of what is possible. With ongoing research and cutting-edge innovations, the dream of interplanetary travel is gradually becoming more attainable. The progress we are making today lays the foundation for the next generation of explorers to venture beyond our Earth, opening up exciting possibilities for the future of space exploration. So keep an eye on the stars and stay tuned as we continue to unlock the secrets of our solar system, and perhaps one day make those dreams of standing on Mars or exploring Jupiter's moons a reality. Don't forget to like this video, subscribe to our channel, and hit the notification bell to stay updated with the latest in space exploration and futuristic technologies. Your support helps us bring you more amazing content.